Hi, Mike with Touch GIS here. Today I'm going to talk about how to measure and record the orientation or attitude of geologic features using our built-in attitude measurement tool. Our attitude measurement tool is a quick, simple, reliable alternative to using a compass and clinometer to take orientation measurements, and it transcribes them directly into your data capture forms. So if you're a field geologist needing to document planar features like bedding dips or linear features like slicken lines and fold hinges, this tool can not only save you time and energy in the field, it can reduce transcription and instrument reading errors and increase the repeatability and reliability for measurements. There's a couple of things I want to go over today. First, we'll create a couple of feature classes that support the attitude data. We'll review the interface and see how the attitude data can augment the feature symbology. And lastly, we'll head out into the field and talk a little bit about how this works and how to take these measurements in practice. Let's get started. First up, let's create a couple of feature classes with the attitude attribute. Now you may already have these feature classes depending on when you install the app, but if you want to create some feature classes of your own, let's walk through how to do that now. First, I'll open the options menu, go into feature classes, and for me, I'm going to use the geology feature class dataset. I'm going to add a new point class, and I'm going to go with a planar feature first. We'll call this bedding dips. Now, first I'm going to add the attitude attribute by tapping on add attribute, and at the bottom of the list, I'm going to select attitude. And you can see here there's a few different options. For planar attitudes, we support both strike and dip direction. And for linear attitudes, we have trend and plunge. For this example, I'm going to go with dip and dip direction. Now I also want this attitude measurement to reflect on the map so I can get a quick sense for the feature's attributes without having to open the feature attribute panel. So first, I'll edit the style, and I'll change this to a symbol that reflects a planar measurement with dip and dip direction attributes. And then I'm also going to update the label and rotation values. So the label on an attitude attribute will always refer to the inclination value. So that's going to be dip for planar attributes, and it's going to be plunge for linear attributes. And when I set the rotation to attitude, that's always going to refer to the directional component. So that's going to be strike or dip direction or trend for linear attributes. And now that I've set up this attitude attribute with this bedding dips feature class, I'll tap back and we'll add a linear one as well. So again, I'm going to add the attribute. I'm going to select trend and plunge this time. And then I'm going to assign a symbol of an arrow for lineation. And then I'm going to set the label and rotation properties to read from the attitude attribute. Now that we've got our feature classes, let's take a look at the attitude measurement tool interface itself. Now you should see a button in the bottom right corner that has a circle with this little T shape inside of it. If you don't see that, you can enable it by opening the options panel, going back to the start, opening the maps section, and finding the line that says display attitude tool and activating the toggle next to that. So if we tap on this button, if this is your first time opening the tool, you're going to see the planar configuration. And let's walk through this interface top to bottom. Up at the top, we have a close button. We also have a settings interface, which we'll get to in a minute. Just below that, we have a toggle for the planar or linear configurations. And then this big dial in the middle, that's kind of the main section of this interface. This dial is meant to give you a quick idea of whether or not the device is calibrated and if it's reading the values kind of as you would expect. You don't have to read the values from this dial directly. You can see just underneath it, there's a much clearer readout for dip direction and dip. So really this dial is to give a quick indication that the device is calibrated and reading kind of what you expect based on your surroundings. To the bottom left of that big dial, we have a smaller dial. This gives you the device's heading in this big number here. So for example, my device's heading is 344, and the red arrow you see, that's a bearing for true north. And just underneath the heading measurement in smaller print, we have the magnetic declination with the lowercase delta sign. So the magnetic declination for me right now is negative 12.56. Now you can tap anywhere on this dial to lock the measurement, which is going to be helpful in the field as you'll see later in the video. Underneath the measurement readout, we can see the selected feature class. Right now this is at. I'm going to change this to be that bedding dip that we just created, and that's just tapping on the feature class and then finding the one we created. And so if I were to tap add point, we would add a point of this selected feature class here. And let's add one just for sake of example now. So let me orient the device, just so we can see how the symbology will change once we add this point. Right now, the dip direction is 174 and the dip is 62. So if I tap add point, and I'm going to move this just so my location indicator doesn't block it, we can see the short leg of this symbol is pointed at 174. And if I deselect it, the label pulls up the dip value of 62. And so that's how the attitude attribute, if configured, can change the symbology of the feature that we just created. Say that I wasn't happy with that measurement, maybe I slipped or I didn't have a good bearing when I was taking it, and I found a better way to take this. I can retake that measurement in two ways, or re-enter this measurement in two ways. For the first one, I can tap on this symbol next to the readout, and that's going to open up the attitude measurement interface with the correct configuration. And so I can replace my device for the measurement and tap record measurement, and that'll update the values there. The other way, say you wanted to retake the measurement using another compass and clinometer, and you want to be able to just key the values in directly, you can tap on those values and that'll open up a menu for you to put those values in directly. So that's how to use the attitude measurement tool for a planar feature. Looking into linear features now, I'll open up that attitude measurement interface again, and I'll toggle over to linear, and you'll see it looks very similar to the planar interface. The biggest difference is this main dial has changed to a kind of clinometer interface where the needle will point to the plunge that the device currently reads. And then also the values down below, trend and plunge, are replacing dip and dip direction. So similar to the planar, I'll add a point to show how the symbology changes with the attitude. And so we can see with a trend of 257 and a plunge of 20, the arrow has been rotated to face the 257 bearing. And if I deselect it, that plunge value of 20 becomes the label. Now, one thing I do want to call out, say your planar feature was configured to use dip and dip direction, but the attitude tool is configured to use strike, which we can do in the settings. If I were to add this point, you'll see that strike value will actually be converted to the appropriate dip direction value using the right-hand rule. So what really matters is what the attribute type that the feature class was configured to use and not which one you see here. That's the value that will be stored. So here we have strike of 071. If I add this point, we should get a dip direction of 161. And as you see, that's what happens here. So now that we've done all that, we've run down the interface and created some feature classes. Let's head out into the field and see how this works in practice and talk a little bit about how the device actually gets these measurements in the first place. Now for planar features, the way this works is we use the compass and other sensors in the device to measure the orientation of the device's surface itself. And so to measure a separate surface, all we need to do is make sure that the surface of the device and the surface we want to measure are parallel, and they'll have the same strike and dip or dip and dip direction measurement. And so the easiest way to do that with a nicely exposed surface like this is just to hold the device up to the surface you want measured, wait for it to stabilize, and we can tap the dial to lock it in, or you can just tap add point to add that to the map. Now, if you want to measure a surface that isn't nicely exposed like this, say it's kind of sandwiched in between a couple of other ones up on a vertical surface, we can, because the key is that the two surfaces are parallel, we can just hold that up to the surface we want to measure, try to line them up as best we can, and then again, lock it in and add the point. Now, for linear features, the way this works is we use the same compass and sensors, but instead of measuring the orientation of the surface of the device, we're measuring the orientation of the line made by the long edge of the device. So one way to visualize this, say you have a pencil and you line it up along the edge, and we take the device away. The trend and plunge of the line made by this pencil, that's the measurement we're going to take. And so to use this on a surface feature, what we want to do is we want to just line up one of the long edges with the surface we want to measure. And it doesn't matter what the angle of the device is. It could be flat, it could be vertical. Again, all that matters is that the long edge is lined up with the feature we want to measure, and then it'll have the same measurements no matter where we go. So once it's lined up and we see it stabilized, we can tap the dial to lock it in, make sure everything looks all right, and then tap add point. That's all there is to it. So we walked through how to create feature classes with planar and linear attitude attributes. We used them to record and update point features using the attitude measurement tool. And we also saw how the attitude attribute can augment the symbology of features on the map, enabling us to get a quick sense for that feature's qualities without having to open the feature attributes panel. I sincerely hope these tools save you time and energy in the field, and I can't wait to hear about how you incorporate them into your workflows. We love to hear from you, so if you have thoughts on how we can improve, please reach out and let us know. Take care for now.